here we are again. This is Wim van Leeuwen here at the Arizona Remote Sensing Center in the School of Natural Resources and the Environment.
And Stuart Marsh,
the director of the School of Natural Resources and the Environment. Today we're going to talk a little bit about multispectral remote sensing systems and kind of introduce you to some topics related to that, different sensors, different multiple bands, hyperspectral band sensors. So hyperspectral meaning many bands, multispectral meaning several bands. And there's many different sensors that you're going to go through in this chapter, talking about weather satellites to land observation satellites, from really detailed resolution to more coarser resolution. And a lot of these different sensors are designed to monitor the Earth's surface as well as the atmosphere and the ocean. So there's many different sensors, and some of these sensors can be just your digital camera, where you have red, green, and blue bands really that make this color picture. But when you have these sensors in the satellites, basically they have multiple bands that are going beyond the visible red, green, and blue. So you use near-infrared reflectance, or you can even use shortwave infrared reflectance, and then even thermal emission, where you have energy emitted from the surface, so you can actually measure temperature as well. So one example of that is Landsat, where you have multiple bands in the visible and the infrared and shortwave infrared, and then you have the thermal band as well. And so that's basically a sun synchronous sensor. It rotates, or it goes around the Earth over the poles and keeps track at the same time as the sun basically, and you basically get an image every time at around 10:30 in the morning. A GO satellite, on the other hand, is a geostationary satellite. It actually keeps the same position with respect to the Earth, and as the Earth rotates, the satellite rotates with it. And that sensor can actually observe the Earth, a big part of the Earth every day, multiple times, where every half hour you get an image for looking at weather, for instance. So there's many sensors around, and here you see another example here. This has 3 channels. It's actually 2 of them are visible and 1 is near infrared, and basically this is a sensor that can image in these 3 bands and create another 3-band image composite basically. And in this case, this is what we call a sensor that has an array of detectors, and there's many different ways of designing a sensor. Sometimes you have these scanning sensors, what we call whisk broom sensors. Other times you have push broom sensors, where you have a large array of detectors that can collect either an image or actually take a whole line and then keep on adding to those lines basically and create an image that way. So like I said, there's many different sensors out there, and I hope that after you read this chapter, you can see the different utilities of the different sensors and the different capabilities that they have. So,
my one piece of advice is to think about categorizing these various sensors that you're going to read about in terms of what we've spoken about before, resolution. So think about it in terms of, does this have a high or a low spatial resolution in terms of the smallest thing that it can detect? Does it have a high or low spectral resolution? Is it 2 or 3 bands or 100 bands? Think about it in terms of temporal resolution. Does it come over every half hour, as Wim mentioned, some satellites do? Or do you have to wait a week or 2 before it comes over? So I think if you think about these and putting them into groups, think about it in terms of resolution.
And those resolutions then determine how you can apply and use these sensors. So if you want to observe weather, like very frequently, like cloud movement, you have to have a satellite that actually sees things very frequently. If you want to look at a city where things might not change as frequently, but maybe every year or something, you might want to use another sensor for that. So global change, forest change, forest fires. I mean, all these different applications will require maybe a different kind of a sensor, and maybe a combination of sensors actually that can complement each other. So in this week, we'll ask you a few questions related to that, discuss those advantages maybe of different sensors and how they can be used all together, maybe to look at an issue related to global change or forest fires or land use, land cover, things like that. So again, you'll be doing a problem set, a quiz first of the chapter that you read, then you're going to do a lab where you'll be discussing some of these sensor advantages and disadvantages, and hopefully continue with that discussion in the next 2 weeks. So you might be recording maybe some of your views on different sensors and create a PowerPoint as well. So I think that's it for this week. I hope to see you next week, and good luck with chapter 7.
Bye-bye.
Bye.